sequential systems. Here we have a state diagram given and we want to design this circuit. Now to design this one, first we have to decide how many of flip-flops we are going to use. To look at that one, what we do is we look at the state numbers. Here we have 4 states. So the number of flip-flop we are going to use is 2 power flip-flop. 2 power flip-flop should be actually greater than or equal to number of states. Number of states. Here, how many states we have? You can see this 1, 2, 3, 4. 4 states mean the flip-flop that we use should be 2 or more than that. This can be 2 or more. If you put like 2 power x and solve for it, that's gonna end up 2. And here we can use like need 2 flip-flops. Need 2 flip-flops. Here we can use the JK flip-flop. First thing we have to do is we have to write the truth table for this. Okay, let's see if I have enough space. I'm gonna do it right here. Let me erase this thing. Okay, let's go. And here first we are gonna write the current states. Current states, that is Q1 and Q2. Then the input, and then next states, and the output. I still need some more space to put the JK flip-flop truth table as well, but I don't have enough space, so I'm going to do this one here and then copy this one and do it in my next page, do it on the next page. So let's do this one for now. Here the input we call it as X, and here the next state is Q1 asterisk, Q2 asterisk, and the output is Z. Okay, now let's bring all of them from the diagram. So here if you look at this, first we have a 0 0, and when you input 0, where it's going back to 0 0. So the next state is 0 0, and the output is whatever the value on the bottom. So bottom here we have 1, so that's the output for the first one, and this is when the input is 0, and that is for 0 0. And when you put 1 as the input for 0 0, okay, here I have to put a 1 here for this question. Okay, so when you put 1 as the input, it going to the 1 0. So the next state is 1 0. When you grab 0 0 and put 1 as input, it's going to the 1 0, and the output there is 1. And let's go to the next one. Here we have 0 1. If you input 0, it's going to 0 0. So 0 0 0, and there we have the output of 1. And if you input 1 for this, okay, this one should be 1 as well, this one should be 1 here. So if you input 1 for this, is going to 1 0, and the output there is 1. Okay, then let's look at the 1 0. If you input 0 for that, is going back to 1 0, so the next state is 1 0, and the output there is 1. And if you grab 1 0 and put 1 to there, like you put 1 as the input, it's going to 1 1, and the output there is 0. Let's look at the last one. The last one we has 1 1. When you input 0 for this, is going to 0 0, and the output there is 1. And if you grab this 1 1, you grab this 1 1 and put input as 1, where it's going to 0 1, and the output there is 0. So this is the truth table we derived from this diagram, given state diagram. Now what we have to do is we have to use JK flip-flop's truth table to combine with this one. Okay, I'm gonna copy this whole thing, put it on the next page. Control C, create a new page and paste it right there. Okay, here we go. We have the whole table. The last one we should be looking at is JK flip-flop. Let's do the JK. Let's write the JK flip-flop alone. Then we can combine with this one, because you have to understand the JK flip-flop behavior first in order to do this one. So let's write the JK flip-flop truth table first. JK flip-flop, J, K, and Q, and the next state. J, K, Q, and the next state. First fill them with the numbers. This is 0, 1. How many total? We have 8 output, 8 different alignment. 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 0, 1, 1, 1, 1. And in JK flip-flop, when you have 0, 0, 0, the next state is 0. When you have 0, 0, 1, the next state is 1. When you have 0, 1, 0, the next state is 0. When you have 0, 1, 1, the next state is 0. And when you have 1, 0, 0, the next state is 1. And when you have 1, 0, 1, the next state is 1. And when you have 1, 1, 0, the next state is 1. And when you have 1, 1, 1, the next state is 0. So here from this one, what we have to do is we have to look at the Q and Q next state behavior. Like when 0, 0, what's the behavior for JK? That's going to be common. Okay. Now let's compare this one. Let's take 0, 0 first. First I'm comparing. Let's create another table, Q and Q next state. Let's create the table right here. I have to erase it, but I'm going to copy this one and put it. I will copy and put it in the next page at the end. Okay. So here I put J. Let's put Q and Q next state first. Q next state, and then JK. Create the column for it. Okay. Now let's look at the behavior. So when Q and Q next states are 0, 0. Q next state are 0, 0. That is these two places. What is happening to JK? J is having 0 and K is also 0 in one location, and J is 0, K is 1 at one location. So 0, 0 for Q, this one 0, 0. You see that J is always 0. J is always 0, but K doesn't matter what it is. It can be a 0, it can be 1. The J is 0, so it don't care. 0, we are going to just look at 4. We are going to grab 2 at a time, so we are going to have 4 different states: 0, 0, 0, 1, 1, 0, 1, 1. Now let's look at the 0, 1 next. Okay, 0, 1. Let's look at this one and this one. So for this one, you can see J is 1 right here in these two places, but K is changing. K is 0 and 1. So who cares what K is? The J is always going to be 1, right? That's what it means. Okay, now let's look at the 1, 0. Let's look at the 1, 0 here. In 1, 0, J is 0, 1 and K is 1. So here, who cares what J is? K is always going to be 1. So J is don't care and K is 1. Let's look at the 1 1. 1 1 here and here. For these two, we have j is 0 and 1. K is 0 0. So who cares what j is? K is always 0. So j is don't care and k is 0. Okay, this is the behavior. Now from this one we have to create the truth table for j1 k1 and j2 k2, because we are going to take two jk flip-flops. First I'm going to erase this one. This is the relation we need. I'm going to erase this one, and I'm going to copy this or cut this. Let's copy this and paste it over here. Okay, I'm bringing it here and erase this one. Okay, let's go. So here we are going to have two flip-flops, jk flip-flops. First one is j1 k1 and the second one is j2 k2. So for these two, what we're going to do is we are going to compare this q and q next state. First we are going to compare the q1 and q1 next state, and then we are going to compare the q2 and q2 next state. Let's compare the q1 and q next state first. So I'm going to highlight this one so you can see which one we are talking about. I'm highlighting this. Oh, it's better to round this one. Okay. So this one we are talking about the q1. We are comparing the q1 and q1 next. Okay, in jk flip-flop, when we have q and next state 0 0, what is the value we have? Jk is going to be 0 and don't care. So the first one is going to be 0 and don't care here, and then we have 0 and 1. For 0 and 1 we have 1 and don't care, and then 0 and 0. For 0 and 0 we have 0 and don't care, and then for 0 and 1 we have 1 and don't care, and for 1 and 1 we have don't care and 0, and 1 and 1 don't care and 0 again, and then 1 and 0, that is don't care and 1, and then 1 and 0 don't care and 1. So this is the truth table for the jk flip-flop, the first jk flip-flop. Now let's look at the next one. Now let me circle with a different color. Now we are looking at these two, q2 and q2 next state. Okay, here we go, q2 and q2 next state. Let's look at the first value. We have 0 0. Let me use the same color here. Okay, first we have 0 0 0 0 word, 0 and don't care, and then 0 0 0 and don't care, and then 1 0 1 0 is don't care and 1, and then 1 and 0, that is don't care and 1, and then 0 and 0, that is 0 and don't care, and then we have 0 and 1, that is 1 and don't care, and then we have 1 and 0, that is don't care and 1, and then we have 1 and 1, that is don't care and 0. Now we have created the truth table for two of these jk flip-flops. The next thing we have to do is we have to take this j1 k1 j2 k2 and create the k-map for all of them. So we are going to take all these four, and also the output is z. So we have to actually have 5 k-map, one for this, one for this, one for this, one for this, and for this. Okay, I'm gonna cut these 5 and put it in the next page. Control C. Now let's go. Copy paste. Oh crap, the C is not here. Let me control that. Let me do it again. Why it's missing? Okay, seems like Z is missing. I had to write the Z, but anyway, let's keep this 4 together. 4 together here, over here, and I'm gonna copy the Z. Let's copy the Z values. For Z, we have okay, we have 1 1 1 1 1. How many ones? 5 ones, 0 1 0. 1 1 1 1 1 0 1 0. Okay, let's create the k-maps. So we have how many, like 1 2 3 4 5 6 7 8 locations, right? So it means this is a 3 input k-map. Let's create them. First one for the J1, and the second one for the J2, and the third one for the K1, and the fourth one for the K2, and the fifth one for the Z. Okay, let's make 8 locations. Okay, now we have 5 k-maps ready. Let's put the variables. Variables is basically q1, q2, q1, q2, and then the x. That's the input. 0 0 1. Let me label this 0 0 0 1 1 1 1 0. Let's use a different color. 0 and 1. 0 zeros. This one also. Okay, let's put the variables first. This is q1, q2, and then x here. q1, q2, and then x. q1, q2, and then x. q1, q2, and then x. Okay, 0 0 0 1 1 1 1 0 0 1 0 0 0 1 1 1 1 0 0 1 0 0 0 1 1 1 1 0 0 1 0 0 0 1 1 1 1 0 0 1. Okay, now let's copy the values we found out. The first one we are looking at the J1. This is the J1, right? Okay. Let's use that red color. This is the J1. This is the K1. This is the J2. This is the K2, and this one is for the Z. For J1, we have 0 1 0 1. Don't care, don't care, don't care, don't care. So 0 1, just follow the numbers. If you don't remember the numbers in k-map, you know, this is the, like, it start from 0 1 2 3, then 4 5 6 7. You have to follow that order when you going from top to bottom. Okay, let me erase this and put the values here. So here we are going to have 0 1 0 1. Let me use a different color here. 0 1 0 1, and then we have don't care, don't care, don't care, don't care. This is for J1. Now for K1, what do you have here? Don't care, don't care, don't care, don't care, and then 0 0. Then we have 1 1. And for J2, what do we have? 0 0, don't care, don't care. We have 0 1, and then don't care, don't care. And for K2, we have don't care, don't care, 1 1, don't care, don't care, 1 0. And for the Z, we have 1 1, 1 1, 1 0, 1 0. Okay, now we have 5 K-maps. 4 is better than 2, 2 is better than 1. Let's see if I can combine anything as 4. For the first one, if I take these two don't cares, I can make this one a 4. So let's do that. If I make this one a 4, what's changing, what's not changing? Q and Q2 changing, so both of them are eliminated. X is remaining the same and X is 1. So this is going to be J1 is equal to X. And let's look at this one. Can I combine this as 4? Yes, I can combine these 4 right here. What is changing, what's not changing? Q1 is changing, 0 1 here, eliminated. Q2 1 1, so it's going to be there. And X is changing, 0 to 1, so it's eliminated. So this one is equal to Q2. Now let's look at this one. Can I combine this one as 4? There's no way I can combine this one as, I can combine this one as 2 here, but I cannot combine this one as 4. So let's take the 2. If I take this 2, what's changing? Q1 not changing, so it's going to be there. What about Q2? Q2 is changing. It's 1 here, 0 here. It's changing, eliminated. Then X is also not changing. If you look at this X right here, this is 1 here, so plus X. Okay. And let's look at the K2. Can I take this as 4? Yes, I can take this 4. If I take this 4, what's the expression? Q is not changing, that is Q1. Q1, and we have to put a not for it because it's a 0. So Q1 not, and Q2 is changing 0 to 1, so it's eliminated. X is also changing, eliminated. And there's another one possible here as well, another 4 possible. I take this 4, and for this one, all the column like Q1, Q2 is changing, eliminated. X is remaining the same, but X is a 0, so I had to put a complement for it. Okay, Q1 bar, X bar. And here, for this one, you can either, do sum of product or product sum. If you take the if you take the ones, that's product of sum. If you take the zeros, that's sum of product. So I can do the sum of product here. If I put the sum of product, the only difference is, you put OR gate instead of an AND gate. Now let's look at this. Here we have Q1. What's changing? Q1 is not changing, right? So this is going to be here, but here we have to put a not because we are looking at zeros, and that is product of sum. Actually, sum of products. Okay, sum of products. So we have to put a not for it because we have to make this one a 0. And Q2 is changing from 1 to 0. It's changing, so it's eliminated. X is remaining the same, but X is a 1, so I had to put a not for it. Okay, that's it. Now we can design our circuit using this. Okay, so after we have done all these, this thing is not necessary, but you know what, Let's copy this thing alone and put it in another page so we don't get confused by all of this. I'm going to create a new page. Let's put the k-map value we found here. First we found out j1 that is equivalent to x. Let's put that one here. And we found out k1 to be what? K1 is equal to q2. Okay. And then we found out j2 is equal to q1 plus x. j2 is equal to q1 plus x. And we found out k2 is equal to q1 naught plus x naught. k2 is equal to q1 naught plus x naught. And then we found out z is equal to q1 naught plus x naught. Z is equal to q1 naught plus x naught. Okay. Now here we are going to take two JK flip-flops. Let's store the JK flip-flops. One here and the other one here. And JK flip-flops comes with J1, the JK input. This is J1, K1 and Q1, Q1 and Q1 naught. Okay. And let's look at the second flip-flop. For this one, this is J2, this is K2, and this is Q2, and this one is Q2 naught. Okay, now we just have to plug all the things we got. We found out that J1 is equal to X. So we have to just attach X to J1 here. And after that, let me use a different color for it. After that, what do you have? K1 is Q2. K1, Q2 right here. Connect them with a line, like bring a line, extend a little bit, put a line like this, connect them. That's it. And J2 is Q1 plus X. Okay, J2 is Q1 plus X. Okay, so to connect with Q1, I can extend this one line like this, put it like this, connect it here, and one wire goes to the X like this, and that's it. The K2 is Q1 naught and X naught. Q1 naught, you can bring it upside like this, and X naught, you connect with X but put a NOT gate for it. Okay, put a NOT gate right here. And the output, you know what, yeah, I have to do one thing here. And J2 expression, let me double check this J2 expression. We got Q1 okay, we have Q1 and X. This is an AND gate, you know, when you're looking at one, this is an AND gate, so this one is multiplication. Q1 X. Okay, there's no plus, so this one is Q1X right here. So the mistake I made here is I had to put the gates for it. That's the only thing I had to change. So here we are connecting with let's look at the J2. J2 we are connecting like this, but we have to actually put an AND gate for it instead of connecting like this. Okay, let's throw the AND gate here. And that is connected with the X and the Q1. Where's the Q1? Q1 is right here. Okay, and this one is connected with the OR gate. Okay, and that is it. And the final thing is output. Output, you can see this is like Q1 naught plus X naught. That's exactly the same as K2. So what I can do here is I can draw a line right here and call it as Z, because it's going to be the exact same thing as K2 Q1 naught plus X naught. And that's it. That's our diagram. That's our design for the given expression. We started from this sequential system, the state diagram, and did all this thing and derived this final design. And that's it for this video, guys. I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.